Hey guys, welcome to the 84th C programming tutorial, and in this tutorial we're going to be talking about the generic binary search algorithm. So we're going to be making the binary search algorithm that we made in the previous tutorial generic so that we can perform the binary search on an array of anything that we want. We could perform the binary search on an array of fraction structs, on an array of student structs, on an array of long longs, whatever we want. So the first thing that we really need to talk about is going to be the prototype for our generic binary search function. It's going to be pretty much the exact same thing as the prototype for the generic linear search function. We still need an array, and this array needs to be a void star so that the caller can pass through an array of anything. They could pass through an array of doubles or whatever. And the second parameter needs to be the size of each element so that we can calculate the address of the element at the current index. And then we need the length so that we can initialize our high variable to something so that we know how long the array is. And then we need a key so that we know what to look for inside of our array, and this too needs to be a void star since the key could be anything. It could be a student struct or a long double or whatever. And then lastly, we need a compare function so that we can actually compare the key and the element at the current index. And this compare function needs to be a little bit more specific than the compare function that we used in the generic linear search. In the generic linear search, really all we cared about is whether or not the element at the current index and the key were equal. However, in the binary search algorithm, we care about which one is greater. So this compare function needs to return a negative number if the first parameter is less than the second parameter. It needs to return a 0 if both parameters are equal, and it needs to return a positive number if the first parameter is greater than the second parameter. And this is just something that we'll have to keep in mind when we're writing our compare function. So the next thing that we're going to be looking at is just the non-generic code. So we're going to be talking about what we actually need to change in the non-generic code to make it generic. And the first one is really pretty obvious. We need to change the prototype, and we need to change the prototype to what we talked about in the previous slide. But the next thing that really stands out is going to be how we actually access the element at the current index. So since we can't use the square brackets on void stars, we're going to have to calculate the address of the current element manually, and that's why we needed the lm size parameter. And then the next thing that we need to change is how we actually compare the key and the element at the current index. We can't use the double equal operator or the less than operator to compare the key and the element at the current index since this is generic. So we have no idea what we're comparing, and the double equal operator doesn't know how to compare two fraction structs or two student structs or any struct that you made. So we need the caller to pass through the compare function. So we'll actually be doing the comparing with the compare function instead of these operators. So this is what the code is going to actually look like. So we didn't really need to change this line right here. We didn't need to change the loop. We didn't need to change how we calculate the current index. But we did have to add in this line of code right here so that we can calculate the address of the current element. And remember from our generic linear search tutorial how we actually calculate the element at the current index. We just had to do the array plus the current index times the element size. Alright, simple as that. And the next thing that we do down here is we call the compare function. We compare the key and the element at the current index. And then if the key and the current element are equal, then the compare function will return 0. So if both the key and the current element are equal, then we found the key, so we have to return the current index. Otherwise, if they're not equal, then we need to see which one is bigger so that we know which side of the current element to look. So if the key is less than the element at the current index, the compare function will return a negative value, so it'd be less than 0. And if the key is actually less than the element at the current index, we need to look to the left. So we need to modify the high variable. Otherwise, we know that the key is greater than the element at the current index, and we need to modify the low variable, which is all stuff we talked about in the previous tutorial. Alright, so that's pretty much all there is. That is exactly the generic binary search algorithm. So now all we're going to do is just test it out in code blocks. So right inside of code blocks right here, I have the algorithm already written out for us. I created a fraction struct, and I started to create a fraction compare function, but we're going to go ahead and finish that together. And then I created a fraction array, so something to search through, and I created a key. So really the only thing that we have to do before we call the generic binary search algorithm is finish this compare function. And remember, this fraction compare function is going to be a little bit different than the fraction compare function that we used in the generic linear search. We have to return a negative value if the first parameter is less than the second parameter. We have to return a 0 if they're both equal, and we have to return a positive value if the first parameter is greater than the second parameter. And to do something like this is a lot easier than you may think. All we have to do is do a subtract. We just have to subtract the fraction 2 value from the fraction 1 value. So we can just say return f1 val minus f2 val. So let's talk a little bit about how this will work. We'll just go ahead and run through a quick example. So we'll say that fraction 1 is 1/2, so we'll say f1 equals 1/2, and we'll say fraction 2 is 1/4. And then we'll just go ahead and convert these into decimals. So 1/2 as a decimal is just 0.50, and then 1/4 as a decimal is just 0.25. So now if we do a subtract, so if we do f1 value minus f2 value, so if we do 0.50 minus 0.25, that gives us a positive number. It gives us 0.25. So we need to return a positive value if the first parameter is greater than the second parameter, and it is. So that's our compare function. That's exactly what we need to do. However, we're not done yet. The result of this subtract right here is a float, obviously, and our compare function returns an integer. So when this function returns, it's going to convert the difference of the subtract right here into an integer. So whenever it converts a float into an integer, all that it does is it just chops off everything after the decimal point. So it's going to chop off this 0.25 and return 0. And that's not accurate because fraction 1 and fraction 2 aren't equal in this case. So our compare function is wrong. One thing that we can do to fix this is just go ahead and multiply the difference of the subtract operation by 100. And this isn't perfect, but it's good enough for our purposes. So before it returns now, it's going to multiply the difference by 100. So it'll multiply this 0.25 by 100, and it will give us 25. And it's a float, so it'll be 0.0000 whatever. So when the function returns, it's going to convert this number right here into an integer. So when it converts it into an integer, it just chops off everything after the decimal place, so it'll return 25. So it'll return a positive number, indicating that the first parameter is greater than the second parameter, which is exactly what we want. So now that we have our compare function done, we can just go ahead and call the generic binary search function. So we'll just say int index so that we can store the return value, and then we'll just call our generic binary search function. So g binary search. The first thing that we need to pass through is just the array that we're searching through, so fracs. The second parameter is going to be the size of each element, so size of fraction, since we have an array of fraction structs. The third parameter is going to be the length of the array. There are 5 fractions inside of our array, so 5. And then we need the key, so what we're actually looking for inside of the array. And the key is going to be a void star, so we have to pass through the address of our key right here. So the address of key. And then lastly, we just need to pass through our compare function. So fract compare. Alright, so now let's talk about what this function should return. Well, our key is 10/12, and inside of our array we have a fraction which is 5/6. And 10/12 and 5/6 are equal, so this generic binary search function right here should just return the index of 5/6, and it will, so it should return 3. So we'll just go ahead and print out index onto our screen, and we should get 3 since 5/6 is at the index of 3. So actually mod I, since we're printing out an integer, and we just print out index. And we run this, and we get 3. So yep, it worked perfectly. Alright, so that's it for this tutorial, so see you guys.